Hi guys, welcome back to the channel. First of all, thank you for watching. Let's say if you have still not done, please subscribe because I see a lot of you are, a lot of you, somebody of you is watching and not subscribing. And tell me what you like, tell me what you don't like. If I have to be, I have to speak slower and so on. And don't forget, this is a project, and I don't have any money for it. If you want just to join the project, please follow the crowdfunding activity. Send something, 10 euro, 5 euro, probably one screw. I can buy with your money also one screw, and it will be really great, really enough. Anyway, this video is to answer to a guy who was as a technician, and he was asking me why I was designing the frame like that and not as a multiple body. I know what does it means. That's why I'm gonna answer. And for the people who doesn't know, please don't look the explanation. So if somebody has seen, I don't know if somebody has seen some videos ago that I was just designing as was some music and cut video really fast and so on, accelerated, and then I was designing the frame in this way, so with several parts. So yeah, I mean, you have a part, you give you make just a sketch, you give a thickness, dimension, the material, well, everything is working fine, everything is working good. You can simulate they are in touch, they are welded together, and this is the frame. Okay, it look nice, but of course, it's not the only way of doing. That's why, for example, this morning I did the cover, some sketch of the cover as a multiple body. What does that mean? You can see that this one is just one part. It's not anymore an assembly as the frame. So here you have several parts. Here you have just one part and several body inside. Each body, let's say, it works by itself, so you can, I don't know, unbend the component, just make it a DXF for cutting, and oh, sorry guys, the color is flip it out. Well, I will fix it later. And yeah, what is the main difference? What is better? What is worse? What is worse for what? Let's say on this way, so making one multiple body, you have at the end only one part that is probably better because the system is lighter. Of course, it's not so great when your boss is coming to you telling you, can we see the last stuff you have done? I have to open, it takes time. So it's better when the file is heavier and you can drink your coffee on Monday morning. On the other hand, yeah, the system will be faster to charge, and well, I think it's stable enough because one of the problem of SolidWorks, it was, I don't know with the last release, but it was stability was crashing a lot, and so more stable, lighter, and in this way, it's, in my opinion, is faster because, for example, I just take the part, I just give you the mate, and yeah, and I can see which is the direction I want to go. So yeah, probably if you want just to understand which is the direction, the multiple part, it's better. If you want, if you have already an idea and if you want to do something else, the best way is to make one part. What does it mean something else? The FEM analysis. If you're gonna define, if you want to verify your part with the FEM analysis, probably you will need to make one part of your component. Why? Because, for example, if you look at the frame and this part, yeah, will be not like that. It will be filled of weldment and will be, let's say, will be a something continuous, will be a continuous body, and for the distribution of the load, for the distribution of the force itself, it's just two parts that are cooperating together. Here will be a discontinuous point, so you for sure here inside, and the touch point, well, let me just say, will be something like that. It's just just let me say only that will be there. And so here you will have, for example, some for sure some trouble, too much load, or the system will give you some wrong information, or something else is, for example, yeah, here is not in touch, so this part are not cooperating, but if for some strange reason they are, ooh, too much, let's say 8 should be enough. Still not enough for the purpose. Let's make out a 10. Yeah, okay, so in this moment they are interfering. So you see anything, the shape is okay, it looks perfect. Of course, the parts are interfered. You can check the interference first before of, say, delivering your part to the manufacturer. But at the end, the FEM analysis will not work. The system will freeze and will tell you, will freeze and will tell you, yeah, 2 or more parts are interfering. You want to check these parts, and if you want to make the FEM analysis, you have to stop it and solve the interference and give the right dimension. And yeah, let's say when, for example, you have some dimension like that, yeah, right, 611 and 42 could be also 611 and 421, so 001 more. And when the crossbar is the right dimension and this is one more, so you will not find it out. So probably you can see here something strange, let's say some any distribution of force and so on, but say is not the best way of doing. So if you want to make the FEM analysis and you want to go deeper in detail to make one part, I think it's way better. If you want just to see which is the direction you want to take and the shape and so on, I think the multiple part is faster. For me, it's faster. So I prefer this way when I have to do something. I prefer this way when I have to make some FEM analysis. It's up to you guys. Something else that I really have to, that I still not clarified, because honestly I was never trying. If anybody of you knows, please let me know. For example, let me say that you are welding the frame here, for example, terrible, so big, weldment is red, it's pretty hot. You weld here, you weld here, and you weld here inside and here inside. Okay, per my experience, these parts will gonna deflect a little bit in this direction. So when you're talking about crossbar on the frame, doesn't really matter. I mean, here probably on the external side, here probably the dimension will be different for sure. Guys, when you really don't care and you have some rubber there and nobody sees it, that's okay, nothing happened. But for example, what I do often is just letting some space, some cut. Let me take this out that I really hate it too much. Good. So I let always some gap here, some half millimeter or 1.5 or 3 millimeters up to the thickness you're welding. So I let some gap here. I make this dimension a little bit smaller than this dimension. So let's say this dimension a little bit smaller than that dimension. And then I give the weldment instruction and I say, please respect the external dimension. Don't undervalue. Sometimes it happened, for example, with a clamp. We were welding the say inside, and that it was, let's say, in the part was deflecting, like I told you, and the insert was not matching. And then, yeah, we find it out that was the weldment that was, let's say, that was deflecting the whole parts. We had to machine it and so on. But this is another story. We will see later when we will design the clamp. Anyway, tell me if you like the video. If you like more this kind of discussion, please let me know. Give me a like. Don't forget, as I told you, to subscribe the channel. Don't forget the crowdfunding if you want to see this machine as real. And guys, thank you for watching. See you soon. Let me go ahead and finish this freaking cover. Bye guys.